Since binomials are the questions most missed by statistics students on the AP exam, let's look at some tips to help us identify if something is binomial. I got this from Penny Smeltzer, an awesome statistics teacher in Austin. Bi, two outcomes, success or failure. Num, a fixed number of trials we call n. I, independent from each other. And all, they all have the same probability of success. I know it's a stretch, but maybe it'll help. Let's look at the binomial equation that you're given on the formula sheet. Probability that x equals k is equal to n over k, that's a combination of n and k, p to the k power, and 1 minus p to the n minus k power. There's your n, number of trials. There's your k, number of successes. P is a probability of success, so 1 minus p is a probability of failure. Now, what does n over k mean in combination? That's n factorial over k factorial times n minus k factorial, which is a number of ways to arrange k successes among n observations. What the calculator will do for you, 12 over 4, is 12 factorial divided by 8 factorial times 4 factorial, and here's the math, 12 times 11 times 10 times 9, yada yada yada, over 8 times 7 all the way to 1 and 4 all the way to 1, which is 495. The cool thing is you really don't have to memorize all that because the calculator is going to do most of the work for you. It's just nice to know what everything looks like. Let's move on.
In roulette, 18 of 38 spaces on the wheel are black. Suppose you observe the next 10 spins of a roulette wheel. What is the probability that exactly half of the spins land on black? We want the probability that x is equal to 5. You must show your work to receive credit, so according to the formula, we'll find the combination of 10 over 5, 10 being the number of trials and 5 is the number of successes. That's a combination, and we'll multiply that times the probability of a success. In this case is 18 out of 38, raised to the probability of successes, which in this case is 5. We're going to multiply that times the probability of a failure, which is 20 out of 38, raised to the n minus k, again 5. You'll get the answer out of your calculator as 0.2427. Depending on which calculator you use, we'll start with the Casio. To get these steps, you go to Menu, 1, Options, Statistics, Distribution, Binomial, BPD. BPD is for one specific answer. That means we will find the probability that we have exactly 5 in 10 tries with a probability of 18 out of 38. You'll notice that it is K, N, P for the Casio. Now let's look at the TI. For the TI, you'll go second vars, which is distribution. You're going to arrow up or down until you find the binomial of PDF. The order for the TI is slightly different. It is NPK. Both Casio and the TI will give you the same answer. The function BCD or BCDF in the TI are for the cumulative probability of the events occurring prior to that number, which is discrete. So if you want the probability that x is going to be less than 7, you're getting the probability of 0, and the probability of 1, the probability of 2, all the way through the probability of 7. So that would be a cumulative probability. If you want the probability that x is greater than or equal to 8, in your calculator you're going to have to take 1 minus the probability that x is less than or equal to 7, once again because these are discrete options. We know Simi is an 85% free throw shooter. He takes 30 free throws. We would expect him to make 25.5 free throws with a standard deviation of 1.9558. This is an average expected value. It's calculated by taking the number times the probability. The standard deviation is calculated by taking the square root of the number times the probability of a miss. If we want to know the probability that his will be making better than one standard deviation away from the mean, we would add his average shot plus one standard deviation for 27.45558. So we want the probability that x is greater than 28. So k is going to be 28. Notice we rounded up. To do this, since we want it to be larger, we will say 1 minus the probability that it is less than or equal to 27. On the Casio, you'll see the steps, and on the TI, we also have the steps there. Again, you must show work from the formula chart to get credit. If you put down the calculator steps, you will not receive credit for that. To receive credit, you'd have to say that x is greater than or equal to 28. So we'll say out of 30, we expect him to make 28 times 0.85 raised to the 28th times 0.15 raised to the second plus ... The last one would be 30 out of 30 times 0.85 raised to the 30th times 0.15 raised to the 0. Again, to receive credit, you must show this work. If we want to find the probability that at most Simi makes 20 of the 30 shots, it would be the probability that x is less than or equal to 20. This is like table A, in that the information you're getting out of your calculator is to the left. See below the Casio and the TI steps. Again, the steps from the calculator will not receive credit, so you'll have to write out the formula. 30 over 0 times 0.85 raised to the 0 times 0.15 raised to the 30th, plus, and then do the last one, which would be 30 over 20 times 0.85 raised to the 20th times 0.15 raised to the 10th. Now you try one. First, we must show that this is a binomial problem. Bi, there are two outcomes, a debit card or not. Nom, a fixed number of outcomes. I, all independent, and all successes have the same probability. What is the probability that exactly 42 teens have a debit card? We want the probability of x is equal to 42. See the calculator steps below. Notice, though, you must also have the work. 350 over 42 times 0.1 raised to the 42nd times 0.9 raised to the 308. That would be 0.0314. What is the probability that at most 42 teens have debit cards? So now we want the probability that x is less than or equal to 42. Again, you have to show your work. 350 over 0 times 10 to the 0 times 0.9 to the 350 plus ... The last one, which is 350 over 42 times 10 to the 42 times 9.9 to the 308 equals 0.9066. The Casio and the TI steps for the calculator are shown below. What is the probability that at least 42 teens have debit cards? You get the idea. See how you did.
All right, here's your homework. Let's get rolling.